Okay, now members, we are going to see an equation. This one is combining an inclined plane and then the pulleys. Let us go through the question. To one end of a light inextensible string is attached a mass of 1 kilogram which rests on a smooth wedge of incline 1 and 2. Now let us start by interpreting the word incline 1 and 2. 1 and 2 means for every 1 unit increase in the height, there is a 2 unit increase in a slope. So always, this one is going to be your slope, and this one is going to be your height of that slope. So now, it means that this is going to be the hypotenuse in simple terms, and this one is going to be the opposite in terms of a right angle triangle. So now, if you are to sketch that, you're telling us that the wedge incline, which is having 1 incline. So now, if you have this now, it means this is going to be the opposite, this is the hypotenuse, and that will give you the sign. So now, if you put our weight there, this is my weight, this is how it's going to be. Like that. Okay, that's my weight there. Okay, this is the theta. Now they are telling me there is a 1 mass particle. This is 1 kilogram. Okay, so that's the first thing I had. Okay, now can we proceed? Let us proceed. The string passes over a smooth fixed pulley at the edge of the weight. So now, here the telling us that there is a fixed pulley, and the string which is holding this is passing over that pulley. It's passing over, and over is a fixed pulley at the edge of the weight, which is there, under a smooth movable pulley. So they are telling us this one will come now and then it will pass under a smooth movable pulley. Under a smooth movable pulley of mass. So this pulley is of mass. Let us first create this pulley. Is of mass 2 kilograms. And over a third fixed pulley, and over, so meaning it's going to continue and pass over a fixed pulley there with a 2 kilogram mass attached to the end of the string. So now, after passing, now this is going to be our third pulley fixed. So meaning we shall have it fixed. I'll fix it. So it's now fixed there. Okay. And here they're telling us that this one is holding a 2 kilogram mass. Then the sketch is done. So it's done to summarize the equation. The rest is just substitute in. Okay. Now that for every weight, for every mass, there's weight acting on it. So you get the mass times gravity. This one is also going to be having the mass times the gravity. This one now, the weight is always acting downwards. So this one is going to be our 1 times B. So because this one is on an incline, we resolve it, it's going to be having a reaction. And then if you have to resolve it, this one is going to be our G cos theta. And then, because this is our theta there, and then this one is going to be G sin theta if you have to resolve it like that. Simple as that. So we have finished resolving that. So now this thing is going to be having tension. Throughout is going to be the same. This one T, then that one is going to be T. So the Y in the first lessons. So after doing this, we have finished all we have to do. The rest is just to consider the masses. So if I start with a 1 kilogram mass, now the acceleration we say now, these are the 2 ends of the string, this end and this end. So we say this one, if this one is going in this direction, this one will be now 2A, and this one, if we assume that it's going in this direction, this is going to be 2A1, then we consider this one to be 2A2. We say you go with the basic. First consider when all of them are going They are said, oh, they are sloping down. So that you can have the acceleration of this moving up in that direction, and actually we said is a half of the sum of these two accelerations to A2, which would be A1 plus A2. I have this, that one cancels. So once you consider the basic, then in your calculations, if you start you get one of them as a negative, it means that the direction was supposed to be opposite. So if you get A1 as negative, it means that the direction was supposed to be like this. Or if you get A2 as negative, it means that the direction was supposed to be like that. So, but always consider the basic, like you see, then they will come out as you calculate. So now after doing that, we have the acceleration of this particle, this pulley, we have this, we have also this. Then we consider the masses. We start with the 1 kilogram mass. Start with the 1 kilogram mass. Then at 1 kilogram, now is that the direction now of the system is now slanting like this, and the acceleration there is 2A1. Remember, R is our that force, is always equal to mass times the acceleration. So what is it? What is pulling this in this direction? So that we have this, so we have B sine theta, then minus, there is a force which is opposing the T. Be put into the mass, which is 1, then times the acceleration, which is 2A1. But from here, you can set our sine theta is going to be a half, which is the same as 0.5. So putting it here, we have now 0.5B minus T equaling to 2A1. When I come to the 2 kilogram mass, I'll come to the pulley later. Now start here, the acceleration is going downwards, so acceleration now is in this direction, and it's 2A2. Or is R resultant force is mass times the acceleration. What's R resultant? You see that the force is in, the acceleration is in this direction, so meaning this is going to be the force minus the one which is opposing. So 2B minus T equal to the mass 2, then the acceleration 2A2. So our 2B here minus T will be 4A2, and I call this equation 2. Now from there, we can come and then consider our pulley. So at our pulley, this pulley here, our pulley, okay, let me consider it here. The pulley mass, pulley mass. So you know that now the pulley is going upwards like this, and the acceleration there is A1 plus A2 using our force resultant equal to MA. Now what is it? What is pulling it up? You see we have this and this. So we have T1, T plus T, then minus, there is a force opposing equal to the mass of this pulley, which is 2, then its acceleration, which is A1 plus A2. So this will be, so that you can write from by 2, but you lose nothing if you go slow. A1, A2, then it's at our T minus B is A1 plus A2, and this will be our third equation. Now, how are we going? We have now three simultaneous equations, and we have three unknowns. We have this, and this because B is always known. Okay, so now what does it mean? It means that we are going to make A1 the subject here and A2 the subject, and we substitute them here. So from here, you can start now our 0.5B minus T, the whole over 2 will give us A1. Then here, 2B minus T over 4 will give us A2. So then we put them in here. So T minus E equaling to A1, 0.5 minus T over 2, then plus A2, which is 2B minus T, the whole over 4. What's the LCM? So the LCM, this is over 1, 2, 4. You get this, but the LCM is 4. But if you don't want, you can just briefly multiply this and this. But here, you can start our LCM is equaling 4. So you multiply through by the LCM, so you shall be having 4 into t minus d equaling to 4 into 0.2 minus t over 2, then plus 4 into 2d minus t over 4. We are doing that so that we can eliminate these denominators by these 2. So here we have 4t minus 4d equaling to, so this is 0.5, please. This will be, I lost the g, which I found. So this will be minus 2 times 0.5, that's 1, then t, then plus 2d minus t. Okay, so now you can see this is going to give us, is there any? I think that's it. Okay, so now this is going to give us, this one is going to give us, so this t, this is going to give us 40, this is going to give us negative 2. When you bring it inside, you get 60 t. Sorry. That is okay. Unless there is our mistake. Yes, that is okay. Is this okay? Okay. So by default here. Okay. Yeah, I think everything is okay there. Okay. So this is going to give us a 6b. I mean 6c. This and this, they are going to give us. So this will give us 60 equaling 2. Now when I take this side, I'll be having, this is going to give me 3, and then this is going to give me b. Unless there is any error which is committed. Okay, so is there any error committed when you are multiplying? Because I'm seeing this was what? 0.5? Okay, let me get a dust and clean it and make it properly. Okay, let us clean this so that we don't, it looks nice. We want it to look nice. Okay, so this one we have 0.5 b minus t the whole over 2 by these 2 ones, by these 2. So this 2 times 0.5 we get 1, this and this we get 2t. So then this will give us 7. Yeah, here we have now 7. So here we have 7t equaling, when we take this is 3, when we add there we get 7d, and our t is going to be d. Okay, so after getting our t, we can come and get our a1. So our a1 is going to be, by the way, this is just 9.8 newtons. That's our d. So our a1 is going to be now 0.5 d, then minus t, the whole over 2, which will be 0.5 d minus 2, which is b, the whole over 2, and our a1 is going to be, this is going to be negative 0.5 over 2. That would be negative, and subtract this from this, 0.5d over 2. Then what about our a2? Our a2, which is supposed to be 2d, now minus t, the whole over 4, which will be now 2d minus d over 4. And our a2 here is going to be d over 4. But you can see this one is the same as if multiplied by 2, negative d over 4. Okay, after doing that, now we have most of the things. We can come and then do our work this side up. Okay, let us do the work. Okay, chop. Okay, now from here we can empty. Let me first also enclose this and gives us some space. Okay, so after getting A1 and A2, I think we have everything. So that's acceleration and the movable pulley. So acceleration, part A, Roman number 1, movable pulley. Our acceleration there is going to be, we said that the movable pulley, the acceleration is going to be A1 plus A2, which will be negative B over 4 plus B over 4, which is 0. So the acceleration is 0 meters per second square, meaning this one wasn't moving. Now, this negative means that the direction you consider here is supposed to be the other way around. So meaning this direction is supposed to be this way. So, meaning that now this was going the other side. That's what this negative means. It means that now the sign was supposed to be opposite. And when you come to 1 kilogram mass, it's Roman number 2. Okay, 1 kilogram mass. Our acceleration there at 1 kilogram mass was supposed to be 2A1, which is going to be 2 into A1, which is negative B over 4, which is negative B over 2. And this one is going to be negative 4.9 meters per second square. What does it mean? It means that it was moving. So our A there, it means that A is equal to 4.9 meters per second, where upward, up along the slope. That's what that negative means. Not down the slope. Now it's up because it's negative. That. Then our 2 kilogram mass, our acceleration there, we said it's going to be 2A2, which will be 2 into B over 4, which will be 9.8 over 2. And our acceleration there is 4.9 meters per second. This one you see, for it it's saying, yeah, it's okay, for it it's downward. Okay, then they want us to get the tension. Our tension is this, so the tension we got it there. So part B, our tension is B, which is 9.8 newtons. That is done. Then the reaction is always, remember, we don't have any acceleration this side, so meaning acceleration is 0. So meaning perpendicular to the plane, these two forces are in equilibrium, meaning R is equal to B cos theta. 9.8, then our cos theta is what? This is root 3, 4 squared, 2 squared minus 1, and the square root. So this will give us root 3 over 2. And so our reaction is going to be 8.4870 newtons is a force. So that's how you handle that question. That's it. I wish you well. Always here I'm emphasizing, please start with this when these two are pulling so that you can have positive there. The interpretation, if you know better, now it means if it's negative, then you shall get this, then minus this, then a half of it. But if you don't know that, treat it the way it is, then you interpret the sign. You interpret the signs here. When it's negative, it means that the acceleration was in opposite direction to that of what you gave it. So it means that this acceleration is supposed to be outside.